Hello everyone, today I'm going to show you two of the best AI upscaler models you can run entirely on your own computer. These tools deliver stunning 4K and even higher resolution results, matching or even surpassing what you'd get from Topaz, one of the most popular paid upscaling solutions out there. Okay, let's get started. First, you'll need to install ComfyUI. You can download it directly from the official website. Just grab the installation package and set it up on your local machine. Once ComfyUI is installed, open it and go to the manager, then select Custom Node Manager. Here, we're going to install some essential custom nodes for the Upscalers. The first one is Seed VR2 Video Upscaler. Make sure you install the nightly version, not the regular one. The normal version is extremely slow and requires a huge amount of virtual RAM, which makes it impractical for most systems. The nightly version, however, includes several major optimizations such as tiling and better memory handling. So again, be sure to install the nightly build. The second node is FlashVSR. This is the one I personally use and have tested extensively. It works perfectly with ComfyUI. There's another version called FlashVSR Ultra Fast. I tried installing that as well, but it doesn't work inside ComfyUI. However, it does work with the non-ComfyUI setup. If you're interested in that version, I've included a video at the end that shows how to install and run it without using ComfyUI. Once both nodes are installed, you can move on to setting up your workflow in ComfyUI. The workflow I'm using here is the standard configuration for the Seed VR2 Video Upscaler V2, which is mainly used for upscaling videos or images. Let me explain how this workflow works. The first node in the workflow loads your video from your local file system. It automatically outputs the video, audio, and other metadata, so you don't have to configure those manually. If your video doesn't contain audio, you can safely remove the audio connections. Otherwise, if you want the audio to automatically merge with the upscaled video, simply connect the audio output to the final output node. The output node combines everything together. It merges all the upscaled frames produced by the Upscaler with the audio track to form a single final video file. Now let's take a closer look at the Upscaler node itself. This node has three main inputs. The first input is images. These are the individual frames extracted from your video. The second input is block swap config. This setting is especially helpful for users with limited virtual RAM. When you enable this option, it allows the system to manage memory usage more efficiently. You can also manually configure the block size for memory swapping. For balanced performance, use a block size of 16. If you want to save even more RAM, you can increase it to 32 or 36, but keep in mind that higher values will slow down processing speed. The third input is extras arguments. This is a newer optimization feature that improves performance, especially for systems with less RAM. For most users, I recommend enabling tiling. Start with smaller values for tile size and overlap, such as 256 for tile size and 32 for overlap. As you monitor your system's RAM usage, gradually increase those values until you find the optimal balance. The goal is to fully utilize your available memory without running into out-of-memory errors. If you're fine-tuning your configuration, enable the debugging options so you can see how your tile sizes affect performance. Next, let's talk about model selection. There are two versions available, a 3 billion parameter model and a 7 billion parameter model. The 7 billion model produces higher quality results but requires much more virtual RAM. The 3 billion model is smaller and faster, which makes it suitable for most systems. Personally, I use the 3 billion FP8 model because it offers the best balance between speed and quality for my workflow. Next is the new resolution setting. This defines the shortest edge of your video frame. For example, if you want to upscale your video to 1080p, just enter 1080 here. The Upscaler will automatically adjust the other dimension to maintain the original aspect ratio. Well, for batch size, I usually set it to 5, but you can experiment with different numbers depending on your system's performance. Well, for color correction, I recommend enabling the wavelet option. This configuration consistently gives me the best results. The remaining settings can generally be left at 0. Once everything is ready, load your video, click Video to upscale, and then press Run to start the upscaling process. Now let's move on to the Flash-VSR Upscaler. A Flash-VSR includes two types of nodes, the basic node and the advanced node. The basic node is very limited. It only allows you to choose the model and the scale factor, and that's all. You can't modify settings like tile size or VAE tiling. Because of that, I don't recommend using the basic version since it's too restrictive. The advanced node is the one I recommend. It provides full control and flexibility. When setting it up, first select the model. I use the low virtual RAM version, which works perfectly even on mid-range hardware. For scale, FlashVSR supports 2x and 4x scaling. However, based on community feedback and my own tests, the 2x mode barely improves image quality and often produces poor results. That's why I always go with 4x scaling, which delivers the best outcome. Compared to Seed VR2, FlashVSR is less flexible. Instead of setting a specific resolution, you simply choose whether to scale by 2 or 4 times. Next, enable tiling. Set tiling to true and adjust the tile size and overlap in the same way as before. Start with small values and gradually increase them during testing until you find the sweet spot. For speed optimization and quality settings, I suggest keeping the default values. If you do want to experiment, here's how it works. Increasing the speed optimization value makes the process faster but reduces fine details. Increasing the quality value improves detail but slows down performance. The stability level setting controls temporal consistency, which affects how stable the frames appear across time. I always leave this at the default value of 11 and it works perfectly. Other settings follow the same logic. Color fix works as before, enable it if you need it. VAE tiling should be enabled on systems with limited RAM. Sage Attention is another useful feature that can significantly increase processing speed. If you don't have Sage Attention installed, disable it. But if you want to use it and aren't sure how to install it, check my previous video where I explain the installation step by step. Precision can stay on its default value, and for the device, select your GPU or CPU as usual. And that's it. Once everything is configured, hit run, and FlashVSR will begin generating your upscaled video. This covers the entire setup process, from installing ComfyUI and configuring Seed VR2 to optimizing FlashVSR for the best balance between speed, performance, and quality. With these settings, you'll be able to achieve excellent video upscaling results even on systems with limited virtual RAM. So that's it for today's video. If you found this helpful, give it a like and let me know in the comments which Upscaler worked best for you. Don't forget to subscribe for more AI tools, model breakdowns, and local setup guides. Thanks for watching, and I'll see you in the next one.